Hi, I'm Kevin Crido and I'm working at Trek this summer as part of the NSF RU Water Resources Program. I'm working on a research project looking at the applicability of CS616 soil water sensors and trying to determine if they were giving proper readings. So what we did is we took a soil sample from our Snapper Creek field site and brought it back here to Trek in the soil box, and we're looking at comparing the tensiometer data to the CS616 soil water sensor. So we set them up side by side here. The tensiometer measures soil water suction, the pull of water into the environment, and measures in units of kilopascals of pressure. And the soil water sensor is located in this part of the box. It measures in units of volumetric water content. So in order to relate the two, we have to develop a soil moisture curve. The soil water sensor downloads data to the data logger every hour. And we also take tensiometer measurements at the same time and build a data set comparing the two different readings. A tempe cell analysis is used to develop a soil moisture curve relating volumetric water content to soil water suction. Tempe cell analysis uses cores of soil samples to determine the volumetric water content at various pressures. The pressure is gradually increased from 0 to 1 bar, and the volume of water that is pushed out of the soil sample at each pressure is recorded. From this information, the volumetric water content of the soil at a given pressure can be determined. This information is then fit to a model of the Van-Genootschen equation or Brooks and Corey equation to create a relationship between the soil water suction and volumetric water content. This information is used for my experiment to relate the tensiometer data to volumetric water content so it can be compared to the soil water sensor data. In order to determine the soil texture of our soil, percent sand, silt, and clay, a hydrometer test was used. A hydrometer is a device that measures a specific gravity of a solution. By taking hydrometer readings at various times, we can determine the percent sand, silt, and clay still in solution based on the principle that different sized particles will fall at different rates. Hydrometer readings are taken by measuring the top of the meniscus that is formed on the manometer. Readings are taken at 30 seconds, 60 seconds, 90 minutes, and 24 hours. And using this data, we can relate the hydrometer readings to percent sand, silt, and clay measurements. The goal of this project was to determine if the soil water sensors are working properly here at the Snapper Creek field site. Through analysis of the soil moisture curve, estimates based on the soil texture, and side-by-side comparison of the tensiometers and soil water sensors, results indicate that the soil water sensors are providing values that are too low. An equation to create a corrected value for the soil water sensors was developed. This information is useful in connecting a water balance at the Snapper Creek site, and completion of this water balance indicated that the soil water sensors' corrected value was providing much more reasonable results. Information from this is also applicable to urban irrigation management and other applications in which these sensors will be used, especially in the South Florida location. Working at Trek this summer, I've gained valuable hands-on experience in both experimental design and carrying out procedures, as well as working in a diverse environment.